Hey everybody, I told you guys I wouldn't be here today, so I thought we could start off with some review bell work for your quiz. On your quiz today, you will only have translations and reflections. You will not have to do any rotations, which was on your homework last night. So if you still had questions over your homework, don't worry about it too much because you will not have to do that on the quiz today. So don't go get your journal unless you already have it. Just take out a piece of paper or write the answers in the margin of the note page if the sub has already given them to you. Number 1, given parallelogram WXYZ with vertices W at -6, -5, X at -2, -5, Y at -1, -8, and Z at -5, -8, under a translation along the vector -1, 4. Remember, this is not a point. This -1, 4 is not a point. That is a vector that is telling you how you're translating your preimage to your image. Find the coordinates of the image of W. Or in other words, the only thing you have to find for number 1 is W prime. You don't have to transform every point. You just have to figure out what the coordinates for W prime would be. So that's what you need to do for number 1. Number 2, given triangle XYZ with vertices X at 0, 4, Y at -3, 4, and Z at -4, -1, under a reflection in the y-axis, find the coordinates of the image of Y. So again, you do not have to reflect every point, but you do need to reflect Y, so you are looking to find what Y prime is. So I would like to have the sub please pause the video at this point. You'll have about 3 minutes. Look in your notes if you need to. Look up how to do translations along a vector to your point, and also look up how to do a reflection in the y-axis for your point. So at this point in time, I would like to have the substitute pause for about 3 minutes, and then we'll come back and we'll check your answers. Okay, so for W prime, what you needed to do was take the point W, -6, -5, and remember, this -1 in the vector is what you're adding to the x value, and this 4 in the vector is what you're adding to the y value. So to get the image for W or W prime, you'll take -6 plus -1, which gives you a -7 for your x value in W prime. Then you'll take 4 and you'll add it to the y value of point W, which is -5. So -5 plus 4 gives you a -1 for the y value of W prime. So your answer for W prime is the point -7, -1. For the reflections, there are three reflection rules that you need to remember for this quiz. One is if you reflect over the x-axis. The other is if you reflect over the x-axis. And lastly, if you reflect over the line y equals x. So that's 3 different rules that we're looking at here. In order to reflect over the y-axis, if you try and visualize it, if you're flipping over the y-axis, the motion rule, if you take your point xy, is that your x value is the only one that's changing. So your x value, you change the sign. So if it's positive, you make it negative. If it's negative, you make it positive. But your y value is not changing at all. Your motion rule on the x-axis, if you're reflecting over the x-axis, you take your point xy, and in order to transform that point under a reflection, this time you're not changing the x value, but you are negating the y value in your point. Notice, when we reflect over the y-axis, we do not change the y value at all in our point. When we reflect over the x-axis, we do not change the x value in our point. The only thing we're changing would be for the y-axis, the x turns to the opposite sign, and for the x-axis, the y value turns to the opposite sign. And then your last motion rule here, if you're reflecting over the line y equals x, you take your point xy, and you don't change the sign at all here. The only thing you do is change the order of the x and y values of your coordinate. So you would change the point xy to actually the order yx in order to get your image. So going back to the question, we are reflecting over the y-axis. So we're going to use this motion rule right here. Reflecting over the y-axis, we will change the x value, we'll change the sign, but the y value will stay the same. So if we go up to point y, the pre-image, that was -3, 4. So the y value stays the same. That means the y value in our image is also 4. But the x-axis, we're changing the sign. Notice it says -x, but you already have a -3. So changing the sign there, a -3, would give you a +3 for your image. So your answer for y prime is 3, 4. So these are the rules that you have to know for your quiz today. You do not have to know any rotation rules at all. Okay, so let's move on to our notes. You should have your note page in front of you now, and if you don't, then this would be a good time for the substitute to pause this and pass out your note page. There really isn't a lot of new information, which is why I am okay doing this before you take your quiz, because really it's going to help us review rotations and reflections and translations. It's just we're doing a composition. And a composition really comes from the word compile. And if you think about compiling information, you're putting a lot of information together. So when we do compositions of transformations, we're actually taking and doing more than one transformation to a given figure. So this is the day that instead of just using a prime, we're actually going to use a double prime, because we'll do 2 transformations to any given point. We're also going to be talking about what a glide reflection is. A glide reflection, so if you want to highlight that, to glide reflect, that's not a very good highlighting job there, but you get what I'm trying to do. Glide is another word for slide or translation. So if we're going to do a glide reflection, we'll slide it first, we'll translate it first, and then we'll reflect it. So you're going to do 2 transformations before you're done. We've got some vocab and some theorems on the front of your note page here, and then the examples are going to be on the back. But we'll just kind of read through this here. Composition of transformations as a definition is the result when a transformation is applied to a figure, which is your pre-image, and then another transformation is also applied to its image. So you're not done with the composition unless you've done 2 transformations at least. We keep seeing this word isometry pop up. Isometry is a word that you would see for vocab on a quiz or a test, and in order for a transformation to be isometric, it means that it does not change the shape or the size of the figure. So a composition of 2 isometries is also an isometry. So let's say our 2 isometries were a reflection and a translation. Well, that means after you reflect it and after you translate it, your end result will still be an isometry. We are not changing the size or the shape at all of our figures today, and nor have we at all in this chapter. Then we have 2 more theorems that talk about reflections. One of them is a reflection across parallel lines, and one of them is a reflection across intersecting lines. The composition of 2 reflections across 2 parallel lines is actually equivalent to a translation. So our pre-image is this blue triangle. I do the first reflection over the first line, and I get the green triangle. And then that image is what I will reflect again over the second line. Now, if I were to take that middle image out and forget that I did that reflection, you can see that to go from the very beginning to the very end, it looks just like a translation. So when you do, that's the theorem, when you do a reflection over 2 parallel lines, it is equivalent to a translation. The composition of 2 reflections across 2 intersecting lines is equivalent to a rotation. So notice here the lines are different, they're intersecting, but again, our pre-image is this blue triangle. So if I reflect the blue triangle over the first line, I arrive at this green triangle, and then if I reflect it again, I arrive at this red triangle. But if I were to take that middle step out, if I were to take the first reflection out, you can see here that from beginning to end, from blue to red, that is equivalent to a rotation. And then our final theorem on this first page is that any translation or rotation is equivalent to a composition of 2 reflections. The difference is, did we reflect it over parallel lines? If we did, that's equivalent to a translation. or did we reflect it over intersecting lines? And if that's true, then it's equivalent to a rotation. Okay, so let's turn to the back of your page and do some examples. Previously, when we did translations, we did it with a ruler, we drew parallel lines, and then we measured the length of the vector. And on those parallel lines, we marked off that same length on every parallel line and then drew our image. So here, our pre-image is triangle DEF. You can use your ruler if you want to, but you don't have to because it's set up here nice for you on dot paper. So I could, just like on a graph, if I had a horizontal line on a graph, I could count the units on a graph. So I start here at my starting point, don't count the points, count the distance. I would count 1, 2, 3, 4, 5, 6, 7. So vector U is 7 units long. So to translate triangle DEF, I will move it over 7 units from every vertex, and then after I translate, I will proceed to reflect across line L. But first things first, let's translate the triangle DEF. So from D, I'll count over 7 units. 1, 2, 3, 4, 5, 6, 7. And we would call that D prime because one transformation has been done. Then I go to point E. 1, 2, 3, 4, 5, 6, 7. So that's where E prime would lie. Do the same thing with F. 1, 2, 3, 4, 5, 6, 7. And that's F prime. Once you have translated each point individually, take your ruler and you can connect D prime, E prime, and F prime. And that gives us our translated image under the vector U. Now, I have translated, I still need to reflect. This is kind of like if we were reflecting over the x-axis because it's a horizontal line. So the key here is that word equidistant that I taught you guys. It means equal distance. A reflection, the pre-image and the image are equidistant from the line of reflection. So what I'm going to do is I'm going to say, okay, E prime, notice I'm not going back to my original figure. I'm going to my image that I've translated. I go to E prime and see that it is 1 above line L. So I'll go 1 below line L, and that will be called E double prime. D prime is up 1, 2, 3, 4 above the line of reflection, so I can go down 1, 2, 3, 4 to get D double prime. And then finally, F prime is above the line of reflection 1 unit, so I go down below, directly below point F prime to get point F double prime. They're both 1 unit away from the line of reflection. And then I will grab my ruler again, which for me is my handy line tool here, and I will graph my final image, which is triangle D prime, sorry, not D prime, D double prime, E double prime, F double prime. So do the transformations in the order that they're given to you. First we translated to get D prime, E prime, and F prime, and then we took that image and reflected to get D double prime, E double prime, and F double prime. I'm going to go ahead and stop this video there. So at this time, I would like to ask the sub to stop this video and go to video 2.